Hi everybody, welcome back to Sensei Kernel Mathematics. Today we're going to be looking at episode 3 of Diffie-Q and linear algebra separable equations. I know it's been a couple days since I last uploaded, but I was busy the past few days and I was writing up for the crazy episode that's going to be coming out tomorrow. It's going to be exciting, it's going to be algebraic properties of solutions. I'm going to try my best to try getting it within just one part of 20 minutes. I'll do my best. Okay, so what is a separable equation? How is it different from what we were looking at before, which was dy over dt plus a of t times y equals 0, or b of t, depending on if it was homogeneous or non-homogeneous? By the way, on that, somebody on one of my last videos was kind enough to comment that I was saying it wrong this whole time. I'm sure I sounded really silly. Sorry about that. But here is the separable equation. And so look, it's just g of t over f of y. How do we start solving this? Just multiply both sides by f of y. And now, what do we do with this? We need to think about something interesting that I want to show you guys right now. So let's make an antiderivative of f of y that we're going to call big F of y. Okay, so the big F of y is just the antiderivative of this, right? Nothing too crazy. And now I want you guys to think about big F of y and then chain rule it. So let's remember the chain rule really quick. You take the derivative of the inside and then multiply it by the derivative of the outside, right? Just going from inside out. So what's the derivative of the inside? It's dy over dt, right? And then we have to multiply by the derivative of the outside, which is dfy of t over dy. See that? And so then we can cancel out this denominator and numerator right here. And then we're left with this. But then the thing is that if this is the derivative of that, and this is the antiderivative of that, shouldn't the derivative of that just be that? It is that. I said that too much, but it's okay. Look at this. Here we go. This is the equation we're working with. And yeah, I believe we're going to do an example now. We are not going to do an example now. Okay, so we back into like how we just solve any of these. We need to integrate both sides and multiply both sides by dt so we can integrate them. Shout out again to the Nizam of Hyderabad. So then remember, this will just become f of y of t, and this will just become the integral of g of t dt plus a constant, an arbitrary constant, right? Now we do an example. This is the equation that we're looking for. Here's our example, right? So we can already look at this example and we can see that we have the g of t on top in the right side, and in the denominator of the right side we have the f of y, right? So we can just identify those really quick, and now we need to find big F of y. Take the antiderivative, right? We'll multiply both sides by f of y first. So what is big F of y? Just take the antiderivative. It's yeah. And so, by the way, guys, for these examples, for my fading out things, I have to put boxes over everything that fade out. And for these examples, I have to put like 50 boxes because there's a ton of steps. Not actually 50, but like a lot of boxes. And it's just so tiring. But yeah. So here's 3 more steps. So this is the format that we decided that we're going to do the equation with in the first place, how we proceed. And we can just plug things back in because we know big F, we know g of t. Just plug them back in and then take the integral of both sides. Now we have this. Then we multiply both sides by 3, and then we get this. And then we get our answer, which is y of t is equal to this. That's it. Very easy, right? We've been doing very similar stuff to this for the first couple episodes. And I hope this does not come as much of a surprise to you guys. If you guys do want to see videos of me working these out more thoroughly, with more detail, please go back to the first videos, because I explain a lot more in detail there. But I am going to be weaning off of kind of explaining all the little algebra rules and all that stuff, because it does take a lot of time. So moving on to particular solutions. Here's how you find the particular solution of it. I know you guys are thinking, hooray, woohoo, big deal, Sensei Kernel Math, you idiot. We've already seen this like 20 times. I know you have. I know it's not very much different from what we were looking at in the last two episodes, but I want to show you guys something interesting. Think about what big F of y of t is. It's the antiderivative of just f of y, right? So when we look at the definite integral versions of this, we get this, right? And wait, aren't these the same thing? Doesn't that mean this is equal to that? It is. It is. Isn't that crazy, guys? I think it's really exciting, and we're gonna see this in action actually in an example that we're about to do right now. So here is the example. If you guys want to work it out, go ahead. I'm about to reveal every step for the example in like 3 seconds. As in now. Here's every step for the example. So you might be thinking, such a kernel math, this format is so stupid, I don't know what it's saying. Okay, just add this to both sides. Now you can see, okay, now we have our f of y here and our g of t here, right? So we can proceed normally, right? And so the antiderivative of e to the power of y is e to the power of y, right? And so I'm not sure why this is here twice, but just ignore it for now. Yeah, so we can just go back to the format that we decided that we can use for particular solutions, set up our definite integrals here and here, right? And so then we just evaluate them. This is e to the power of y minus e to the power of 1. Here is our, like, you know the procedure for taking a definite integral of something, right? Then we even everything out. 1/2 plus 1/4 is equal to 3/4, and we subtract that, and then we add e to both sides, and then everything's so close, but we need to isolate this y on the left side, so we multiply everything by ln, so we can do that, and then here is our solution. Brilliant, right? We have it right now. Also, I am going to do one more example, just for the giggles and hee-haws. I know y'all love giggles and hee-haws. So let's look at this example right here. And now again, you might be thinking, that's kernel math. I don't even know what the format is. What are you doing? And to that I say, stop yelling at me. It's really rude, and I don't like it. But yeah, so there is a procedure for this. We just need to demystify the components of it. So first of all, we know right here, we can see a y right here, so this is f of y, right? So let's divide both sides by f of y like usual. And so then we have 1 on this side, because dividing something by something is just going to be 1, right? We can just say that's g of t because it can be, right? We also do have the y of 0 up here is equal to 0, right? I didn't go into much detail on that in the last example. Sorry about that. So then we could set up our proper integral here, right? And then so the thing is, here is our y of 0, as we can see here, and the t of 0 right here, right? And then look at this right here. I get that there's spoilers here because I was lazy with the boxes, so sue me. But look at this. 1 over 1 plus y squared. Is the integral of that? Is the integral of that arctan y? It's arctan y, isn't it? Yeah, arctan. But yeah, we can evaluate this integral right here, the definite integral, arctan y minus arctan of 0, which is 0, and then just t minus 0 for this guy right here. And we have arctan y is equal to t, and then we have to even everything out. The inverse of arctan is going to be tan, and then here we have it right here, guys. Isn't this amazing? When I first saw this, I was like, I was genuinely jumping up and down. I was running around, giving everybody like hugs and throwing confetti everywhere. I was super excited. I hope y'all were excited as me too. But yeah, that's the whole episode. That's the whole episode, guys. Next one is going to be crazy compared to this one. Thank you for watching, and I'll see y'all next time.